are insatiable model makers. We look at anything and try to see some kind of patterns in it. Quite often these patterns are silly, weasel-shaped clouds, but we take a real joy in experiencing the world with our senses and seeing patterns and beauty in it. And when we say joy, I think we can also, that's an evolutionary shaped reaction to some for some useful behaviour. However, I think the models that really please us are unifying patterns or unitary models. I appreciate that other animals can understand simple phenomena. Starlings can use stones to crack snail shells. My dog understands that a cloth can be used as a blanket and will drag one out into the garden. However, animals usually seem content with isolated phenomena, while people seek patterns that connect these phenomena together. I think the evolutionary survival advantage of this is obvious. These unifying and unitary models are efficient at predicting large amounts of phenomena, lots of things that happen to us, and this allows us to manipulate our environment to our advantage. For human beings, seeing patterns and building models confers real survival advantage. I suppose the next question is, where do these models come from? It seems likely to me that our minds simply try and instinctively construct models and unifying themes. Non-productive intellectual constructs, flights of fancy, are selected against. They fail to replicate and we forget them, whilst useful things find a niche and interlock and intermesh with other ideas, and we have a tendency to produce ever more complex unitary models. Now, if these models are essential for our survival, how do we produce better models? Well, one possibility, I suppose, would be to produce a bigger brain, and I think evolution has done that for us. But we've now, and for some time, have the largest brain that we can have. The human brain simply cannot get any bigger. Human babies, or at least not much bigger, human babies are born with brains about a third adult brain capacity. Hugely expensive to run and make. The birthing process is extremely difficult, and the babies that are born are premature compared with other animals. So it seems that we've reached a physical limit. You can't make the woman's hips wider to fit a bigger head through, because then the woman would, or women wouldn't be able to walk properly. So we've reached a kind of physical limit. So if we can't produce a bigger brain, how about more brains? We can't, and the same thing with senses. How about more eyes? Well, that seems to me exactly what we've done. We've introduced language, and language can allow the sharing of sensory information and the sharing of processing that information. If I speak to you, you can begin to see the world through my eyes. You're gathering sensory information from me. Similarly, if I listen to you, I can see the world through your eyes. Not only that, we can share the processing of that information to produce a more efficient model of the world. So language is allowing information to flow from individual too individual. And I would argue that it is language and this flow of language that allows memetic evolution. That ideas can now be represented or in the form of language, and that this is a digital or at least particulate-like medium which is separate from the phenotypic effects that it causes. Language itself does not change things. What language can do is it can change things through the effects that it causes. And I think it is language that a memetic view has been lacking. I believe that language allows us to reintroduce or introduce a Weissman-like barrier between inert code and the phenotypic effects that code causes. Okay, thank you, and we'll explore this a little more in the next video.